Hello, welcome to this video. Today we're going to look at this integral. We have sine to the mx and cosine to the nx. Multiply them together, we're trying to find the antiderivative. And I should mention, it doesn't really matter, but m and n are natural numbers. If they're not natural numbers, it's much harder to figure out what to do, and you need it's much harder to figure out what to do in those cases. But if if m and n are natural numbers, you'll see we'll be able to find a recursive formula for this integral. So what we're gonna do, like I said, we're gonna find a recursive formula, which will turn this power m to n minus 2. And then if we had an integral, like say sine to the power of 6 times cosine to the power of 2, you could demote that sine to the 6 into sine to the 4. And you'll have some expression, but the only integral you'll have is sine to the 4 times cosine to the 2, and then sine to the 2 times cosine to the 2, and then at the end you'll have cosine to the 2, and the integral of cosine squared we know how to get. So that's like an example of how we'll be able to apply this formula. So let's just begin. So the real thing to do here is to do integration by parts and to understand on which things to do integration by parts. So what I'm going to do is separate it like this. I'll have sine to the m minus 1 x times cosine to the nx sine x dx. Okay, so we've separated our integral, our product like so. Now we're going to use integration by parts. We're going to let u equal sine to the m minus 1 x, and then du is m minus 1 times sine to the m minus 2x, and then we're also multiplying it by the derivative of sine, which is cosine. And next we're saying dv is the rest, which is cosine to the nx sine x dx. Of course there's a dx here, I forgot. And now we need to take the integral of this, but you notice if you take this specific integral, you can actually do a u substitution of cosine x, and it'll have negative the integral of u to the n, since negative sine x is the derivative of cosine x, and the integral of that will turn out to be, I'll leave it for you to do the rest, is negative cosine to the n plus 1x over n plus 1. So this is u dv, and now we have our dv and du. So now let's see, this is the integral of u dv, but now this is u times v, which is 1 over n plus 1 sine to the m minus 1x cosine to the n plus 1x minus the integral of v du, but notice, because we have a negative with v, it's actually going to be plus the integral of this without the minus sign times this. And so we'll have plus, and actually I almost forgot a negative sign here from the v, so u times v, we have negative sign with v, and now this is plus the integral. We have, I'm going to take m minus 1 and n minus 1 out of the integral already, so m minus 1 over n plus 1 times the integral of sine to the m minus 2x cosine to the n plus 2x dx. Now it seems as if we made our problem harder. as even though we've decreased our power by 2 on sine, we increased it by 2 on cosine. So if we try to use this as a recursive formula, we'll end up with an integral of cosine to the power of m plus n or something, and that we don't know still how to evaluate for now, so this will not really work. However, what will work is if we use the Pythagorean identity of sine and cosine, which states that sine squared x plus cosine squared x is equal to 1. If we use that, you can notice that we can separate this cosine to the minus 2, this cosine to the nx, which is what we had at the beginning, which is fine, times the cosine squared x dx. And now I'll separate it. I'll separate this cosine squared by 1 minus sine squared x, and I'll have 1 over, copy this, negative 1 over n plus 1, sine to the m minus 1x, cosine to the n plus 1x, plus m minus 1 over plus 1 times. Okay, so cosine squared is 1 minus sine squared, and so from the 1, we'll get just the integral of sine to the m minus 2x, cosine to the nx dx, which is good. The only thing we did is decreased the power of sine. We haven't increased anything, so we'll be able to use this to go down until we okay, so this is what we get from the 1 minus, now we have sine to the 2, and so sine to the 2 times sine to the m minus 2 is just sine to the m. So this is sine to the mx, cosine to the nx dx. Now we actually have an equation for the integral of sine to the mx cosine to the nx dx. And if we move this to the other side and divide by the appropriate coefficient, we'll actually get ourselves the recursive formula that we desire. So let's add m minus 1 over n plus 1 times the integral of sine to the mx cosine to the nx dx to both sides. So here we'll have 1 plus m minus 1 over n plus 1 times the integral of sine to the mx cosine to the nx dx. And now this is equal to negative 1 over n plus 1 sine to the m minus 1x cosine to the n plus 1x plus m minus 1 over n plus 1 is the integral of sine m minus 2x cosine to the nx dx. Alright, now notice 1 plus m minus 1 over n plus 1. This thing is just m plus n over n plus 1. And so, first of all, we can multiply by n plus 1 to get rid of all these denominators. And now we will divide by m plus n to get, finally, our recursive formula. Sine to the mx cosine to the nx dx is equal to negative 1 over m plus n sine to the n minus 1x cosine to the n plus 1x plus n minus 1 over m plus n, the integral of sine n minus 2x cosine to the nx dx. Alright, and we can really use this as a recursive formula, as the only thing that changed in our integral was this power turned from m to m minus 2. So we'll be able to work it down until we eventually hit a power of 0 or 1, which are easier to deal with. So now let's use examples to see really how to work with this recursive formula. And so let's clean the board, put this at the top, and evaluate a specific integral. Alright, let's evaluate this thing. So this is our recursive formula. Let's evaluate this. We have the integral of sine to the 6x cosine squared x. So let's just apply the formula. In our case, m is equal to 6 and n is equal to 2. So we'll get negative 1 over 8 times the sine of x to the power of 5 cosine cubed x plus 5 over 8 times the integral of sine to the 4th x cosine squared x dx. Okay? And now let's continue, because we can use this recursive formula on this integral now. We have negative 1 over 8 sine to the 5th x cosine cubed x plus, now I'll take 5 over 8 out of this entire thing, and this integral is negative 1 over, so m is 4 and n is 2, so this is 1 over 6 sine cubed x cosine cubed x plus, we have 3 over 6, which happens to be a half, times the integral of sine squared x cosine squared x x. Okay, now we'll take it out of the brackets just to make it look a bit nicer. So you have negative 1 over 8. Now, at this point, you don't really need the recursive formula, as you can turn this into sine squared 2x and then turn it into cosine 4x or 1 minus cosine 4x and evaluate from there, but I still want to continue. So we'll use the recursive formula again. So okay, so now m is equal to 2 and n is equal to 2, so this is negative 1 over 4 sine x cosine cubed x plus, we have 1 over 4, the integral of, now we have sine to the 0x with x which is 1, so we can ignore it. So this is cosine squared x dx. Alright, let's take it out of the brackets again, and now I will not be using the recursive formula on integral of cosine squared. Instead, I'm going to evaluate the sort of normal way by multiplying and dividing by 2 and turning it into 1 plus cosine 2x. So, first of all, let's write the other parts down. Okay. So, I've taken it out of the brackets and multiplied it and divided by 2 to get the integral of 2 cosine squared x. And, because now 2 cosine squared is 1 plus cosine 2x. This is 1 plus cosine 2x dx. Now this integral is x plus sine 2x over 2. But sine 2x over 2 is, because I still want to fit with the sine to the power times cosine to the power, sine 2x over 2 is sine x cosine x, meaning that this integral evaluates to x plus sine x cosine x, and so when we take it out, we get our final result of negative 1 over 8, and of course plus c. Alright, that is the result of this integral, and now, just as another final thing, if instead we have cosine x to the power of 4. We would end up at the end with the integral of cosine to the 4x, which is harder to evaluate. Here we got lucky and we already had a smart way to evaluate the integral of cosine squared. But for cosine to the 4th, how do we do that? Well, you can actually get a similar recursive formula for this, but instead of changing the power of sine, you change the power of cosine. And the way to do that is by doing a u substitution here of x is equal to pi over 2 minus u, which will give a negative at the start, and we'll swap the sine and cosine. And then you'll be able to use the recursive formula like so, and then when you switch u back to x, you'll end up with a recursive formula, but for the power of cosine instead of sine. And then that's how you'll be able to also demote the power of cosine until you have one of the 4 integrals. The integral of 1, the integral of sine, the integral of cosine, or the integral of sine cosine. And we know how to deal with all 4, meaning that you can really evaluate any integral you want like this and turn it into a sum of coefficients times products of powers of sine times powers of cosine, and maybe an x. Okay, finally, that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more interesting problems and things like this in the future. And finally, that's it.